Hi and welcome to a lesson on OSPF routing. So far we've done static routing where it's a very efficient protocol, good for small networks, but it becomes an administrative headache as the network grows, and having to modify and manage every change on the network becomes difficult with static routing. So OSPF, which means open shortest path first, has less overhead. It learns and updates its own database from its neighbours. So we're going to set up 3 OSPF routers, and we only have to tell each router about its neighbours. We don't have to tell it about routers that are not its neighbours, because it will learn about those from other areas. We're going to work with a one area, which is 30 to 40 routers. You can stick on one area. After that, you need to have multiple areas. The benefits of OSPF is that it only updates its database when there's a change. If there's no change, there's no update sent around the network. So that means there's less administrative effort on the router, less CPU, less RAM, less memory being taken up. So we'll have to start off by configuring the network as always. So before we can start OSPF, we need to build ourselves a quick network. I'll try to go through this quickly as I can. So let's go to our devices, and I'm going to pick the PT router. I'll have 3 of those. And then I'm going to take 2 PCs which I'm going to put on 2 different networks. I'm going to connect these cables up. I'm going to use the auto. So that's SE20 and SE20, and this therefore will be 3 to 2, 20 and 3, and finally this will be 3 to 3 probably, SE3 to SE3, and finally from fast Ethernet 0 to 00 there, and again to that. So that's our network quickly constructed. What IP range is, how are we going to set this up? Well, this will become the 10.0.0.0 network. This will become the 11.0.0 network, and this will become the 12.0.0 network. So for example, an example address is going to be 11.0.0.1, and there'll be 255.0.0.0, and then this is going to be the 192.168.2.0 network, and an example address will be 192.168.2.1, and that will be 255.255.255.0. We need to know these subnet masks because they'll be very important in a few minutes. And I just need to put in another one here, 192.168.1.0 network. Okay, so there's our networks configured. How am I going to configure each of these routers? I'm going to do 10.0.0.1 for SE20. I'm going to have to set it, this router is connected to the 10 network, the 12 network, and the 192.168.1 network. So, and I know that was SE3, so this will be 12.0.0.1 will become SE30, and finally on the FA00 will be 192.168.1.254. So that's how I'm going to configure this particular router. I'm going to configure this one as 10.0.0.2 for SE20, and I'm going to configure 11.0.0.1 for SE30. That's all I need to do in this one. And then finally this one is going to be configured as, that went to, yeah, so that will be 11.0.0.2 because I used 1 there for SE20, and 12.0.0.2 because I used 1 there for SE30, and finally FA00 will be 192.168.2.254. So those are the IP addresses I'm going to configure them as. So let's configure the PCs first of all. So this can be 192.168.1.1, and I've said I'm going to give it the gateway 254. 192.168.1.254. Okay, so we save that, and I'm just going to do the same here. And 192.168.2.1, and that will be 192.168.2.254. Okay, so there's the PCs configured. So now we're going to need to just add IP addresses to the routers. We know how to do this, we've done it before, but I'll quickly go into it. CLI, no for configuration, and I'm going to enable, and I'm going to conf t, and now that I'm in there, I'm going to go through my interfaces. I'll do them in the order that they're here. So I will do interface SE20, and I will do IP address 10.0.0.1, subnet mask 255.0.0.0. I'll set a clock rate of 64,000, and I am going to do no shut for no shutdown. And you see that it's gone from administratively down to down because the other end hasn't been configured yet. So I'll exit out of that interface, and this time I will go into interface 30, and I'll do IP address 12.0.0.1 255.0.0.0, and I'll do no shut, and that's changed it down, and exit out of that one again, and this time I need to go to interface FA00. IP address is going to be 192.168.1.254. That's what I wrote there. Subnet mask 255.255.0, and when I click no shutdown this time, that link will go green. So we're now configured correctly there. We could try pinging, and it's successful. So we've set that one up correctly. Now we're going to go into this router. We don't want to configure it at this point. Enable. Okay, I haven't typed in no IP domain lookup, so I'm going to cheat. I'm not going to wait for this to time out. I'm going to click that a few times. So what I can do is, I'll go into enable, conf t, and I can type in no IP domain dash lookup. Typos a lot today. Okay, so I've put that command in. So if I make any more typos, it'll avoid the timeouts. So there's the settings I'm going to put in. So interface SE20, and I'm going to do IP address 10.0.0.2 255.0.0.0, and exit. Oh no, no shut actually. what I can do is I can put a clock rate on here, but I've already done it on the other end, so it'll tell me there's no need to. So I can type in clock rate 64,000, but it tells me it's already done. So I can exit this, and this time go into SE30 and type in IP address 11001, and no shut. Sometimes it's easier to type things in than it is to just keep on pressing the up key and all the rest of it. So if I end this, if I was to type in, let's have a look, show IP interface brief, it's showing me I've done 10.0.0.2, which I wanted, and 11.0.0.1, which I wanted. If I wanted to check this one, I could end all the way out, show IP interface brief, and I can see I've done 192.168.1.254, which I wanted, 10.0.0.1, 12.0.0.1. So we're almost there. The last one was these three settings: command line interface, no, enable conf t. I can type in no IP domain dash lookup. If I wanted to as well, I could do host name router 3. Okay, that's just a reminder of a couple of commands, the basic ones you've already learned really. So this time I'm going to go to interface SE20 I've done first there, so let's go into that one. IP address is going to be 11.0.0.2, 255.0.0.0. Clock rate 64,000. Okay, it's already been set up, that's good. And no shut. Okay, and as you can see, the links now come up. Exit and interface SE30 next. IP address was going to be 12.0.0.2, 255.0.0.0, and that'll be no shut, and that's going to bring that interface up. And finally, exit and interface FA0-0, and I'm going to do IP address 192.168.2.254, 255.255.255.0. No shut. Okay, and now if I was to end all that, show IP interface brief 192.168.2, 11.0.0.2, 12.0.0.2, it's all set up. If I do my envelope between here and here, successful. If I do it from here to here, it's going to fail. All I've got is directly connected routes. So if I was to go back into this and type show IP protocol, where are we? So show IP, end that. Let's have a look. If I did show IP route, then you can see that I got connected, connected, connected. Everything will be connected. So but I haven't got any show IP route. Good job I put in the so everything's connected. So I've got no networking, I've got no OSPF set up. So I'm going to set up OSPF on this first router. So the benefits of OSPF, I have to tell it about this network, I have to tell it about this network, because it's all directly connected. I don't need to tell it about the 11 network, and I don't need to tell it about the 192.168.2 network. They are irrelevant to me. I don't need that. I just need to tell it about the directly connected. It'll learn everything else it needs from its neighbors. So let's go into this. I'm going to go to conft, configure terminal. I'm going to have to type in the router OSPF 1 command, and now I need to start putting in the wildcards. So basically, I'll put the first one in, network. So the network it needs to learn was the 10.0.0 network, 10.0.0.0. But the trick is now, the 10.0.0 network is 255.0.0.0. We have to reverse this. So that becomes 0, and zeros become 255s. So 255 becomes a 0, 0 becomes 255. So I type in, for this one, 0.255.255.255, and we're going to be working in area 0. Okay, so as I mentioned earlier, they were just doing one area, so area 0. So I've told it it's connected to the 10 network, but it's also connected to the 12 network. So I can just press the up arrow, change it to 12, and I can enter. And finally, it's connected to the 168.1 network. So network 192.168.1.0 network, and that network is 0.0.0.255. 0.0.0.255 area 0, and that should get us set up quite nicely. So if I end that and I do, let's have a look, show IP route, you'll see that it's still not learnt any OSP. It's all got connected. It hasn't learnt any OSPF yet. It's going to learn that when we've configured its neighbor. So we'll pop into the neighbor and get things started. Again, this is only directly connected. So configure terminal, and I'll do router OSPF1 and network 10.0.0.0. That's the network it's on. It's on 2, 10 and 11, and it'll be a wildcard 0, 255, 255, 255. So then it'll be 0.255.255.255, and that'll be area 0, because we're all in the same area. And I'll put in 11, and what you'll notice is it just came up just before I pressed the button, process 1 neighbor 192.168.1.254, which is this one, has loaded its database from it. Okay, so it's already learnt. So if I go to end all of this and I do show IP route now, you'll see it's got O and O for OSPF. So I only typed in 2, but from this network, it's learned the 12 network and it's learned the 1 network. So unlike static routes, it's learned its way around the network. So we've configured that quite nicely. The last one, configure these. So I'm nearly there. So conft and router OSPF1, and we need to set it up for 11, 12 and 192.168.2. So I'll type in network, I'll put in 11.0.0.0 and then it'll be the reverse, so it'll be 0.255.255.255 and area 0, and then it should find some net, it should learn a little bit when I do that, if we give it a few seconds. And what I'll do is I'll make a mistake on the next one, so you can see it's learnt network, so it's now learnt about some information from its neighbour. I'll make a deliberate mistake on the next one, so this next one I'll do the 12 network, but I'll put it into area 1, and this will really send things into panic mode, hopefully. I'll put in 1. Why is it not letting me do that? 12. Okay, I'll type it in myself. Keyboard's gone a bit... Okay, my keyboard's gone a bit strange, but... Okay, my keyboard glitched a bit there, I didn't quite know what happened there. I've changed it to area 1, and what we should find is it should, yeah, so it starts to throw us all kinds of errors, and it's saying received invalid packet, mismatch area ID from backbone area must be virtual link. If I end this and I go to show IP route, you'll see no, I'll do show IP route OSPF. Let's try that. Show IP route OSPF. And basically it'll keep throwing this error out all the time because I've added in a wrong area, and it just keeps going through and through and through until I fix it. So if you do that, it's not the end of the world. We know it was 12.0.0 that problem happened. So if I go to conft and then I go to router OSPF 1, and then I type in network, I know I typed in error there, so I type in network 12.0.0.0, and then it was 0.255.255.255 area 0, and you'll see it's changed from area 1 to area 0. So all you've got to do is remember which one you made the mistake on, show IP protocol, show IP route, and those commands will help you put it back. So the last one I need to do is network 192.168.2.0, and that will be 0.0.0.255, and that'll be area 0, and that'll learn something in a few minutes. And we've now should have configured everything. So if I end this, if I do show IP route, you'll see we've got all the routes learned. It's learned from its neighbors. If I did show IP, that command doesn't seem to be show IP protocol. And when you type in show IP, after you do done OSPF, you show IP protocol, and it's got area 0. So when I put that one in the wrong one on purpose, this is what I was trying to show you, where you could see what it was all working. So we've set up OSPF all correctly now. So if I ping, you'll see it all works. Everything gets around the network. If I do a trace route, OSPF, so I'll type in command prompt there. If I try to trace route to this one, which was 192.168.2.1, so I'll type in trace route 192.168.2.1, it should go straight across the 12 network to the 192.168.2 network. And as you can see, it's done 2 hops. It's gone straight there. It didn't go over there and over there because it was a quicker one. So if we have an error on your network and you lose your link, if I now ping that one, you'll notice this time it's gone 10, 11 and to 2. So it's gone 10, 11 to 2. And if I look at these routers, it's telling us neighbor interface is down or detached. So it's worked out that the neighbor's got a problem, and these will be doing the same as well. They'll all be identifying that a neighbor is down or an interface is detached. So it's worked out a new route. So it's gone 4 hops. If I put that cable back, oops, no. So my mistake. If I put the cable back, and I now go back to this, it's gonna still remember the old route for a few minutes. And so if I go to the router, it's now saying it's changed the state to app, so it's gonna share its database. Its database is being shared, and by about now it should be back to just 3 hops. And you can see, whereas before it was going 10, 11, now it's going straight through to the 12 network. So as you can see, it always works out the shortest hop. And just to demonstrate finally one more thing about how easy this is, and how with static routing you'd have to put a new route in. So if I add a new PC to this network and I connect it up from there to there, I'm going to call this the 192.168.3 network. So 192.168.3, and the PC will be .1, and it'll be 255.255.255.0. So let's quickly go in and configure this PC. Oops, wrong one. Desktop. .192.168.3.1 I said, and the gateway will be 192.168.3.254. Okay, so I've configured the PC. I now need to go in and very quickly configure this router. So conf t excuse me, and I need to go interface FA00, IP address 192.168.3.254, 255.255.255.0, no shut, and then that should go green. So now if I ping, everything's successful. If I ping from here to here, it can't do it. It doesn't know about the route. If we look at these, there's no route as such to be learned yet. So if I get that ready, so now I'll go to this router again, and this time I'll exit out of that, and I'll do router OSPF1, and I'll do network 192.168.3.0, and it's going to be 0.255.255.255, and it's area 0. Now we should see any minute now it'll pop up, or the others will pop up, that they've learned about a new network. So we'll give it a few seconds. So if I go to this one, so look. So if I ping from here to here now, it's successful. If I ping from here to here, it's successful. And you'll see that the routers will start to share their information, and they'll start to populate. So if I go to show IP route now, it shows me 192.168.1, and it shows me 3 there. If I go to this one and I end and I do show IP route, you see it's also learnt about the 3. I haven't had to put all that in, it's learnt about it. And just as one final test, if I want to ping this one here, 192.168.1.1, the shortest route is 10 and here. So if I do trace route 192.168.1.1, you'll see that it goes straight through 10 and it's there. If I wanted to ping 2.1, it's going to go to the 11 network. And it's done it. And that basically is OSPF. It's always going to find the shortest route. If something does go wrong, let's have a look. Oops, hang on. If something does go wrong, and we try to ping, so this time trace route 192.168.2.1, this time it's going to have to go all the way around because the link isn't there. So it's gone 10 and 12, and again these routers will all be notifying, will all be saying that there's a one down. This one, they're all saying that then there's a problem with their neighbor. So, and then as soon as I put the link back, and I ping, it'll need a bit of time to alert everything that it's back up and running, change the state to up, and then it's gone from up to loading done. So now it'll find the shortest route. So that is OSPF in a nutshell, really. It's a clever protocol, it's got low overhead, and it's pretty easy to set up and a less administrative headache. Thank you for watching.